Hello, I'd like to first start by thanking the session organizer, Roger Pang, for putting together such a great idea and collection of speakers. I'm very honored to be a part. And I'd also like to thank the conference organizers and the conference attendees for having patience with my remote presentation or pre-recorded presentation. I just welcomed a new family member to my family, a little baby boy, only 4 weeks ago, so I was unable to travel to Washington to be with you. But hopefully you'll enjoy this pre-recorded talk anyways. So today I'm going to talk about reproducibility and point out the obvious that you could do data analysis without it. But then I'm going to ask you the question whether you think you should do this or not. Do you think this is a good idea? I'm hoping that by the end of this talk, I will convince you all that it's not a good idea. And despite the added effort and work that goes into doing reproducible data analysis, you really should do it. And we really should consider this as part of what we think of as a theory of data analysis. So before we dive into this topic and my argument further, I think it's first important to define what is reproducibility. I adopt the definition of reproducibility that it is reaching the same result given the same input, computational methods, and conditions. This is a definition that was arrived on by many committees with the National Academy of Sciences in 2019. And here, if we dive into this definition, we're going to say that the input is the data in the case of data analysis. The computational methods likely or should be computer code, and the conditions would be the computational environment. So sometimes if you're working in R, you might think of like an RM environment, or if you're working in Python, maybe it's a virtual env or a conda environment, that sort of thing. So we're going to be focusing on reproducibility in this talk and in my argument, and I want to make a point that this is distinct from replicability, robustness, and generalizability when we think about data analysis. All of these things are important, but they have different definitions and apply in different ways. So reproducibility is when you have the same data, the same code, the same computational conditions, and hopefully get the same outputs. Replicability is different in that you have perhaps the same code and analysis, but you'd be working with different data. And then you can see in this chart down here that robustness is working with the same data, but using different code and analysis, whereas generalizability is using both different code and analysis and different data. All of these things are important for science, and we aspire to doing these things across many studies when answering a question, but within a single study and a single data analysis project, that's what I'm going to be focusing on today with reproducibility, that we're talking about the same data and the same code and analysis. And I just want to say that this is a wonderful slide put together by Joelle Pineau, and you can read more about it in her archive paper here. So how does reproducibility then fit in with a theory and methods for building a successful data analysis, which is what this session is about? Well, reproducible data analysis can help make an analysis successful by helping build trust in the analysis. This is really important for your stakeholders. And these stakeholders who are going to be using the application of your data analysis to make decisions, to have a product that they perhaps sell, that they perhaps will be building future studies on, is really important. And so, for example, a reproducible analysis can provide evidence that the results or the product could be regenerated given the same input, computational methods, and conditions. Reproducibility also allows for transparency. So another human can take a look at the work and the analysis that you've done and audit all the steps that were taken during analysis. And then finally, if you version control your analysis, there's also a complete record, not only of the final state of the analysis, but the process you took to get there. And you can look at that record and figure out how and why analysis decisions were made, which are sometimes quite hidden in data analysis. Another way that this fits in with building a successful data analysis, or why it should be part of a theory for such, is that reproducible data analysis can help make an analysis successful by helping with efficiency of performing the analysis. At first glance, you might not agree with me because it takes more work and effort to do things in a reproducible way, but I'm hoping to convince you with a little bit of data that I'll present later that without these reproducible methods, we do end up usually wasting more time than it would take to put into using those things. So How much time you spend on a data analysis is really less important from an ethical lens. So in the previous slide, I talk about trust, and that's, I think, maybe more important. But from a financial or business perspective, efficiency is really important. This could be like efficiency of your grant funds, or if you're working in industry, this is your business. And what I'm going to hopefully talk to you about and show you is that this appears to be the most obvious pain point for data scientists and organization when reproducibility failures occur. So in some of the courses that I taught in the past year, I did an activity with my students where I asked them to tell me and share with me past reproducibility failures or workflow challenges that they faced either at school or on the job in the past. So I teach courses at the undergraduate level, third-year undergraduate, but most of the respondents in this survey were graduate students in a Master of Data Science program, and many of these students have had past jobs or past degrees where they were doing research and working with data. So I collected 66 stories. And when we looked at, or when I went through and read the stories and coded them by the main themes related to reproducibility failures, 4 main themes arose. The most of the failures were due to what the students attributed as something related to not using version control or not using version control effectively. The next one would be code, so doing analysis without using code or without recording the code. The third is missing documentation, and the fourth is environments, computational environments. Looking at these stories, I also coded what were the impacts of these reproducibility failures that the students described from their stories. And by far, time was the most impact or most frequently reported impact of reproducibility failures. So we can see that well over 80% of the students reported that time, or indicated in their stories that time was lost. Other things that were reported to be lost were reputation or confidence. Sometimes their work was discarded. Sometimes the project wasn't discarded, but there was an unfixable error. And then sometimes there were financial costs as well. Time is also tied in with financial costs because salaries cost money. So it's important to think about that as well. So here are some representative stories from these students, just so you can see what is the flavor of the problems that the students described in their past work. So here is one from a student. They say, when I was working with my last company, my team had a large data set stored regarding some traffic data in the database, and I wrote a script to retrieve the data and do data analysis in a single Jupyter notebook without putting proper documentation or comments. The project was then tabled for a few months. But then a summer intern came and was assigned to pick up the project. So I had to explain everything in the notebook to her, but I had no idea what I wrote since the logic was not quite straightforward. It was also hard to set up the environment on her laptop since we had a bunch of libraries and dependencies used in the notebook. We finally took a week or two to set the environment up and transfer the knowledge to the intern, which was really a waste of time. So here we have the reproducibility failure being insufficient documentation and the impact being this loss of time. Another story is, in my line of work, my colleagues and I heavily relied on SQL queries to withdraw data from a database. She always forgot to save the queries while just sending me an Excel file to read. Sometimes, well, most of the time, when I cross-checked the data, the results didn't match. It usually required hours of troubleshooting to figure out where the gap was between my query and her data. So in this case, we have a reproducibility failure that's the methods not being recorded as code. Code was actually input to do the SQL query, but it was just tossed away. And so we don't have this recording of code. And again, the impact of this reproducibility failure was time. And the third story here is, when I was working on my last job creating a database, I was working between 2 different computer systems. I had written the code on my local computer, which was a Windows machine, but it was being deployed on a Linux command line system. To debug my code, it was easier to do that on my computer, but certain lines of code were specific to the Linux machine compared to the Windows machine. While I was using version control, I had a really hard time keeping track of which script was which, and it caused me to waste lots of time and energy trying to fix this issue. So here we have another reproducibility failure. They're using code, they're using version control, but the problem is the differences in environments between the different machines. So their lack of using a shippable and shareable computation environment like RM or virtualenv or Conda or Docker was what led to this problem. And again, the impact of the reproducibility failure is the loss of time. So what the stories that the students shared with me really, when I read through them, demonstrated that the data scientist strongly feels an impact when we use non-reproducible analysis for our data analysis. However, the organization and science and beyond the organization, science and society can also be impacted by lack of reproducibility in analysis. So to summarize the potential impacts of the data scientist from those stories, mostly was time, which means decreased productivity. And then the second biggest one was reputation. Students described embarrassment and loss of confidence as well. Thinking about the organization, if we take the flip side and think about the data scientist students reporting their time being lost, well, that is actually an increased salary cost payout on the organization. Again, whether that's like salaries from a grant in a lab, in a research lab, or whether that's salaries from a business. The organization can also have reputational or embarrassment issues if they are delayed in their project, or if they bring a product to market or a result to a client that's not correct. They can suffer work being discarded, which could slow things down, and either work not being delivered on time or incorrect work could result in liability costs for the organization. Potential impacts that could happen beyond the organization that could affect science and society could be, are irreproducible and thus untrustworthy analysis published in journals that are taken as truth. Well, we don't say truth in science, but as probably quite accurate when they very well might not be. I'll describe a case later where we have retracted articles that persist in the literature from their citation that seemed fine previous to their retraction. So that can be an issue. And then delays in rollout of initiatives or products from which are downstream of data analysis can happen if we don't use reproducible methods and we have our analyses delayed. So I'm going to talk just briefly now, highlight 2 cases of analysis with reproducibility failures. The first is a machine learning study that was published in Nature in 2020. And then the second is a randomized controlled trial that was published in Scientific Reports in 2021. So in 2020, there was a paper published that was titled International Evaluation of an AI System for Breast Cancer Screening. This was initially lauded as a very exciting and interesting paper. They claimed that they had created an artificial intelligence system that beat human experts in predicting breast cancer. So very exciting. And this is from a group at Google. And this was published in January of 2020. However, with the interest of this paper, many experts outside of this research group read it and discovered that there was a lot of issues with the ability to reproduce this work. So a large group of researchers got together in October 2020 and published a Matters Arising commentary, which particularly described many reproducible issues with the paper. So there was missing code, definitions of hyperparameters for the model's architecture were missing, details of the training pipeline were missing, and many other things. The commentary also proposed recommendations for this paper and future papers to avoid such issues in the paper. There was probably some back and forth communication between the journal and the original authors and this group who wrote the commentary, because in October 2020, the original authors also published a reply to the commentary where they acknowledged some of the reproducibility issues and how they addressed them in an addendum that was also published that month. However, they also attempted to justify where they were not able or willing to address other reproducibility issues pointed out in the commentary. So it got a little bit better from this, but not completely better from this. So this caused a bunch of extra work and issues with it caused some, reputation damage, I would say, to the group at Google who originally published this, although they did put effort forward to improve it. One upside from this is that this caused the commentary caused some positive movements in the machine learning community for making a case and procedures and an expectation for improving reproducibility. So the reproducibility issues in this paper are not unique, and they've been observed to occur in many machine learning and other data analysis papers. So one of the authors, Joël Pineau, came up with a machine learning reproducibility checklist as a result of this commentary and her related work. And this checklist was actually used at NeurIPS in 2019, which is a prominent machine learning conference. And it correlated with an increase in researchers including code with their paper submissions to that conference to 74%, which was in previous years, it was less than 50%. So sometimes when we have reproducibility failures and they can do have costs like reputation or confidence costs, some positive things can come out of it. And I see some of the things here that I'm listing here as some positives. A second case that I want to highlight is a paper that was published in Scientific Reports about the efficacy of comparing two drugs for COVID-19 in a randomized controlled trial. And this research paper proposed that one of the drugs was safe as an alternative to another drug in mild or moderate COVID-19 infected patients. So this was published in March 2021. And then in September 2021, the paper was retracted by the editors, in part due to reproducibility issues. So there were data versioning problems with it. There were issues where the authors had used SPSS to do the data analysis and hadn't shared enough information about the methods that they were not able to reliably recreate the results, and a few other questions. So this paper was in part retracted due to these reproducibility issues. And so this is, really detrimental to the authors and detrimental to the scientific community. So one problem, the problem doesn't just stop when the article is retracted. Between the time the article was published and retracted, this article was cited 17 times. So there's 17 citations out there where how would I say this? Where the people thought that the authors thought that this was correct and there was no problem with this study. And so those citations can lead to propagation problems and persistence of this, truth or accurate information that really isn't truthful or accurate. So here I'm just going to summarize the points that I've made in my talk. So first is that reproducibility means reaching the same result given the same data, code, and computational environment. The second is that reproducibility should be included in a theory for successful data analysis because it contributes to trustworthy analysis as well as it increases the efficiency of performing the analysis. Third, the most commonly reported reproducibility failures, at least from data scientists in training, are version control failures, lack of using code failures, and lack of documentation, followed by lack of using shippable and shareable environments. And the most commonly reported cost is time. And hopefully I've demonstrated that non-reproducible analysis can have impact on the data scientist, the organization that the data scientists work for, and beyond with science and society. So I'd like to acknowledge the UBC Master of Data Science students and the UBC DSci 310 students who shared their stories with me that I've used to share with you today, as well as Joel Osblom, a new assistant professor of teaching in the Department of Statistics at UBC. He's a co-author with me on a pedagogical paper on teaching reproducibility, where some of these ideas came from. Some references in case folks are interested in looking at this further. And then I want to leave you with this parting question. Reproducibility. You can do data analysis without it, but should you? I hope you say no after this talk. Apologies that I can't be here to answer questions, but please do feel free to ping me on Twitter or email me, and I would be very happy to discuss this further. Thank you.